Now we're doing FreeCodeCamp Legacy Python for everybody. Python objects. All right. So let's go. Let's get to it.
Hello and welcome to Python Objects.
All right. So Python Objects is chapter 14. All right. So let's do that first in our notes. Let's come down here and let's go grab. I mean, you can do this if you want. I'm doing this because I need it. We're going to, at some point, we're going to write some Python to slap this on the web automatically, but not right now, but later. So that's why we need these little breaks, so there's something to parse easily. So let's put 10 whatever, 10:02 24. All right, so we're good here, and let's start with chapter 1.4. What was it called? Objects. Python objects. All right, so there we go. We're ready to cruise through this. Let's go.
Charles Severance, and we're well on our way to getting through all this material in the Python. So this
very real. Warning to start with. Let's write down this warning. I've never seen this in my X years of life. Pardon me. In my variable years of life. Oh, what is this? Warning. All right. Warning. A warning. A warning. Ding. All right. What? Okay. The following is very much about definitions and mechanics for objects. What? The following is a lot more about how it works and less about how it's used. Okay. So I guess this is some woke crap from whenever he recorded this. Because he recorded these, I'm pretty sure he recorded these ones in 2019 and he recorded those other ones like we were doing yesterday in like 2016, right? So in 2019 there was a lot of woke BS going on. And he's probably having to write this because he's got to mollycoddle a bunch of sissies. Haha. You won't, we won't the what? We won't get the entire picture until this is all looked at in the context of a real problem. Okay. So please suspend disbelief and learn technique for the next 50 or so slides. You know what? We're not going to put this warning because it's stupid. You know, it's one of those, I don't know. It's not for us. It's not for us. We're going regardless of what is written down. We don't have any luxury of saying, we can't use this.
Is in a weird place. I even debated all this material in the Python.
All right, here we go.
So this lecture is in a weird place. I even debated where to put it in the book. I don't really want to teach you how to write a lot of object-oriented programming, but we're going to start using objects, and I want to be able to use the terminology. And so as much as anything, this lecture is about terminology and understanding the words, things like methods and method signatures and variables and inheritance. And so think of this as a terminology lecture rather than a learn how to program or learn how to use this. It's not something you're going to figure out right away. And there'll come a time when you...
Okay. Listen, I took public speaking quite a few times back when I was young. And the thing about it is you don't have to tell your audience what's behind the curtains. In fact, they don't care. They don't want to know. Fact is, isn't that what I'm doing now?
You as a programmer really want to start using object-oriented programming. It's really a powerful and wonderful technique, but I think it's too early as a beginning programmer to really say, oh, let's write a bunch of objects. So just relax and enjoy and learn this material and think of it as sort of a a theoretical thing rather than, a how to program thing.
Okay. Will do.
And so
all right. So let's, instead of this, whatever, let's do this. Data structures. All right. Okay. So let's just write down data structures. Data structure. Okay. It's just a statement about what's going to happen. More on lists. Okay. We're going to have to listen to this because this is not normal.
Part of this is we're going to start reading data structures and data on how to use all these libraries, etc. And we're going to see the word objects, right? And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And
all right, let's look at this. So this chapter is going to describe some things we've learned about, already in more detail, and add some new things as well. More on lists. List data type has some the list data type has some more methods. Here are all the methods of list objects. List append X. We're going to add an item to the into the list. Equivalent is this. Okay. Extend, insert, remove, and pop. Okay. Oh. I'm having trouble understanding. Hey, what's going on, Udo? What? I have two. Oh, no, it's not frozen. It's paused.
So, the word object.
That's not me. That's the guy who made this video that we're watching. I'm a handsome. I'm sorry. I've got okay, look, my hairline is like this, okay? There is a little bit of skin showing like here, but my hair goes like this, and then it does this, and then it comes back down here. And my beard is like this, and it's wild. That ain't me. I'm very, just saying. Anyway, so like I'd put my picture up there, but you'd be like, hey, we want to see you more. And I'm just like, hey, I don't want to shave every day. I'm sorry, guys. I'm not doing that. Regardless. So here we go. Blah, 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 blah. Okay. I think that we're not going to write these down because there are just so many different methods in programming for so many different languages that, it's better to know how to find them than how to memorizing them. You know what I'm saying? Something like that. So we're just going to skip on. We're not going to write these down. We're not going to write these down.
Should make sense to you, even though
back up.
On how to use all these libraries, etc. And we're going to see the word objects, right?
True.
And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And so, the word object should make sense to you, even though you're not going to write a lot of object-oriented programming. And so,
oh my God, what the hell is this? What is this? Is he just showing us page upon page of documentation? I guess that's what's going on here. Honestly, I think this is like a course on the harsh reality of the fact that there's just so much written down about this stuff, and we may or may not have to read it. But luckily, we have ChatGPT these days. All right, so this okay, we don't need to know about that yet at all.
On page, database stuff, which we're going to talk about soon, is uses objects all over the place, and the beautiful soup uses objects. We've kind of been using them, and I've been waving my hands, and I use the word method without defining it. But now it's really time to define it and go to it. So
this might be the real stuff.
I want to review from the very beginning what we think of as a.
Okay, we can write this down. So what did that say? Review of programs. All right, let's write this down. We don't need this. Review of programs. Review of programs. Okay. What is this? Oh, we don't need a review. We know what a program is. Let's just let him go through the review. We'll wait until we get some good stuff.
program. So the classic program, my favorite little minimum program, is our little elevator floor converter, which converts from European elevator floors to United States elevator floors.
We've done this.
And the key to this is that it's input, processing, and output. And this is a good way to model any program. And in that process, we've got variables, and we've got logic, we've got algorithms, we've got loops that we write, we've got all kinds of things. And we construct a series of steps to achieve some goal. In object-oriented, and frankly, you've been using object.
Okay. Review of programs. Yeah, we had to have written this down already. But let's do this. Let's write this down. I mean, we did object-oriented programming in the JavaScript, but we never really like sat down and wrote notes about it. So let's try again. All right, let's type object-oriented. Okay, let's say programming anyway, because I can't stand that. Programming. And if it's no good, we'll delete that. All right, so a program is made up of many cooperating objects, okay? Instead of being the whole program, each object is a little island, a little island. Little island within the program, and cooperatively working with other objects. Okay. A program is made up of one or more objects working together. Yes. Objects. Hold on. There we go. Objects. Let's go down one. Make use of each other's capabilities. True. Okay. So a program is made up of many cooperating objects. Yes, I believe so also. Very modular. If you've ever heard the term modular, it's like modules, objects, modules. It seems like the same thing, except for, never mind. Back up on the module thing. Because modules are more like something that just fits in automatically kind of thing. Anyway, whatever. So a program is made of many cooperating objects. True. Instead of being the whole program, each object is a little island within the program, cooperatively working with other objects. I would say an island, but on the picture for this course right here where you see like the gears and stuff, I would say it's more like the gears, or maybe like anyway, I don't want to think about an analogy right now. But yeah, let's say little island. I don't like islands though, because islands aren't necessarily useful. You know what I'm saying? Like a gear in a watch is going to be useful. A gear in a factory is going to be useful, or we're going to throw it away and get something that is useful. You know what I'm saying? Island, it's just the volcano. That's what I think of when I think of an island. It's a volcano going and palm trees and stuff. So a program is made up of one or more objects working together. True. Objects make use of each other's capabilities. Yes. So it's just like a big company, or any kind of thing that's like the cells in a body, the organs in a body, any kind of like system, that's what an object is, or that's what object-oriented programming is. Anyway, so let's go.
Object-oriented all along. The program has lots of objects, and we're sort of putting stuff into these objects, taking stuff out of one object and putting it into another object.
True.
And you've actually been doing this all along. As soon as you're
Yes.
looking at dictionaries and lists, you're doing objects. And so an object is quite a little thing. It's sort of its own little space inside of a program that contains code and data. And so we're working together. All these objects are now working together. It's a bit of...
All right. Before we go any further and find out what it's a bit of, we're going to throw object onto this screen thusly. Object. All right. So an object, we're not capitalizing that. An object is a bit of self-contained code and data. We're not capitalizing that either. Code and data. All right. A key aspect of the object approach is to break the problem into smaller. I think this is honestly any approach when it comes to problem solving, but yes, this one too, to smaller, understandable parts. Divide and conquer. I thought that was like a military tactic, but okay. Objects have boundaries. I don't know. Look, divide and conquer. Number one, we're not at war. All right, we're not doing that. Let's call it something more. Let's just leave that out. How about that? Okay. Objects have. Where are we? Boundaries that allow us to ignore unneeded. Is that how we do that? We're doing it today. Detail. All right. And we have been using objects all along. String objects. We're not capitalizing that. Strings. String objects. We can do it. Integer objects. Dictionary objects, etc. Boom. We got the point. Let's go.
Of self-contained code. So we're working together. All these objects are now working together. It's a bit of self-contained code and data, and it is one way to take a very complex problem and make it easier by breaking it into separate things that can be engineered and developed separately. So
synergy, stuff like that.
Or maybe you'd use Beautiful Soup or something. These are powerful capabilities, and if you had to look at all of them, it's just, hey, here's a thing, use this object, it'll do these things for you, and there's lots of details inside of it. Just don't look at it. Don't worry about it.
No, so not that. You look, okay. That what he just said, don't look at it. That's not, no. That's not how it is. You can do that if you want. If you want to just throw somebody else's code in your project without looking at it, you can do that, but not me. Okay. I want to know every pixel and every single character that goes into my code. I'm not going to be just trusting, hey, yo, bro, just trust me. Yeah. No, that's how you go to prison, because somebody used you as a tool, right? Speaking not from experience, but from, you see things over the years. Anyway, don't trust anybody. Make your own code. Let's go.
Things that you can use, things that you can look at, and things that really you don't bother looking at. You go read the documentation and use it, and away it goes. But then someone had to write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects.
Yeah. Good idea. All right, what is this? So input, yeah, that's how a computer works. I, with my keyboard, put some blah, blah, blah into the computer, and then the monitor gives us that. That's what happens. We're not writing this down.
And so if we think of this program that originally just sort of did processing,
conflict
as having some kind of an input, right? coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries.
Yeah, a computer, we get it.
We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings in the first week, first lecture, first week, first everything.
True.
We were using objects, and we've been using them all along.
We have been.
And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so
True.
a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application.
True.
And one of
all right, what is going on here? Objects hide detail. They allow us to ignore the detail of the rest of the program. Oh yeah, this is the whatever. Objects are bits of code and data. I don't know. Objects get created and used. Okay, I didn't realize that this was changing over here, honestly. Okay. So should we be writing this down? Objects hide details. Okay, we're going to write this down, but we're going to, okay. Objects get created and used. We know that. Objects are bits of code and data. That's gray area. I think we know that, but we probably want to write that down. It's not trivial yet. We're still in objects, so let's just write it right here. Objects are bits of code and data. And I don't think he's talking like bits as in like actual, computer bits. I think he's talking like bits like as in like whatever. A literary object or something. I don't know. Let's go forward a little bit. Hold on. Let's do it like this. Forward. Object hide detail. All right. Let's write that down too. All right. Objects hide detail. We're going to put a semicolon. They allow us to ignore the rest of the program. Oops. Ignore that. Rest of the program. There we go. All right, so let's go.
One of the nice things about the object-oriented pattern is that they form boundaries. And within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a beautiful soup object. And I'm going to build this capability, and I'm going to give it to you in the form of an interface. And I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it. And the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like inside the object, they don't have to worry about what you're doing with the object outside of it. When you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things.
Like I'm not look, I know what's going on here. I know what's going on here. But the more words he's blah, 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 blah. It's like what he's putting so many words for walk straight forward or this does this whatever. Maybe I'm adding to it. I don't know. Let's go.
Comment and give things to it and use functionality within that object. But we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And so it's a very nice pattern. And so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big blob of stuff. So.
Yeah, nah, you do. Just keep going forward because, you know, I'm on Python right now, you know, so just keep moving forward with JavaScript and then get to, you know, you'll get here if you want to, right? That's it. If you want to get to Python, you can get here. It's really not necessary to learn Python. I'm just learning it because, you know. But yeah, you're welcome for the videos, and yeah, keep watching. Keep doing what you're doing. You'll get through it. Let's go. Definitions. Class. Template. Dog. What?
Some definitions in this space, words that I want you to understand.
What? What is? Okay, we're gonna write this down. Let's do a definition section. Definitions, but we're not gonna write down dog on class because that doesn't even make sense. Definitions. All right, class. A template. Okay. Method or message. Okay. A defined capability of a class. Oh, it's the example. So a template, a dog. A dog. I don't want to write dog though. All right, we'll just skip the little end parts. Field or attribute. Field or attribute. We are capitalizing that one. A bit of data inside the class. Data inside of a class. Object or instance. A particular instance of a class. Oh. A particular instance of a class. All right. So the template would be the dog. I'm gonna bring this way over here. Watch this. Let's do something like this. Hey, what's going on, Chell? Yeah, I'm glad. So what are we doing here? So class. All right, we're gonna say example. Maybe we should do example. So examples. No, let's do it here. Let's say a dog. All right, so the method of the message would be bark, would be the bark method, the bark method, like that. And then we would also have the length of the dog, I guess. Length. Lassie. Okay. So Lassie the dog is the actual instance of it. There would be a length of the dog, I guess. There would be a bark of the dog, and then it's the dog itself. This looks like stuff where this looks like we're getting into like the prototypes in JavaScript right here. So yeah, it seems like that's what we're about to be doing. So let's go.
And we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it. We have to be able to define the shape of this object. What code will each object have in it, and what data will each object have?
Okay. We're going to go talk to ChatGPT just for a split second. Just for a split second, we're going to come over here and say, are Python objects and JavaScript, what is those things called? Prototypes. The same thing. Let's see. Somewhat similar purposes, but both in that they both help define objects, Python objects, class-based. Okay. So what's the Python? So what's the JS equivalent to Python objects? JavaScript Come on. Oh yeah, never mind. Okay. 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 I see. Pretty much the same. But what about this class crap? I thought that was the prototypes. Anyway, we'll get into that. Let's go.
Have in it, and that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great, mental model of how it works. The class,
except for you put dog.
The
there.
class, oops.
What?
The class is the template, and then the object are all of the cookies that are made from that template.
I see.
The template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class. And there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function. But it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use. If you look in some object-oriented patterns like Smalltalk or Apple, they often will call these messages. So you can either access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access.
Okay. I was really, every time he flashed this, I was just ignoring it, but here it is. Let's get to typing. All right, so terminology class. We'll write that. Why not? Terminology. It's a stupid looking word, isn't it? Class. All right. Okay, let's write this down. Like this, I guess. A class defines a class. Defines the abstract characteristics of a thing. Oh, okay. Or an object. Including the thing's characteristics. Oh, its attributes, fields, or properties. And the thing's behavior. The things it can do, or methods, operations, or features. All right. One might say that a class is a blueprint. Is a blueprint or factory that describes the nature of something. For example, the class dog, dog would consist of traits shared by all dogs. True. Such as breed and fur color. And fur color. Which are characteristics. Characteristics. All right. And the ability to bark and sit. Behaviors, which are behaviors. Behaviors. True. Okay, so let's read this again. So a class defines the abstract characteristics of a thing or an object, including the thing's characteristics, its attributes, fields, or properties, and the thing's behaviors, the things it can do or methods, operations, or features. One might say that a class is a blueprint or factory that describes the nature of something. For example, the class dog would consist of traits shared by all dogs, such as breed and fur color. Yes, which are the characteristics and the behaviors. All right, where did it say behaviors? Anyway, so let's say, I guess the cookie cutter is the class, right? That's what they're saying. And then, but the thing is, the cookie cutter doesn't tell the cookie to taste sweet. But anyway, it doesn't matter. We know, look, it's a bad analogy, a cookie cutter, because a cookie cutter doesn't make a cookie taste sweet. And some dogs don't bark, you know? But I guess that's the difference in behaviors. I don't know. Anyway, so yeah, this is what this says, and this came from Wikipedia, so let's go.
So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter.
Oh, nice making that big thing into a sentence and a half. Lassie. All right, let's do terminology class. Okay. Pattern exemplar of a class. All right. I guess we're just adding to this one. A pattern exemplar. I've never seen that. Okay, exemplar of a class. That's not even a sentence. All right. Okay, whatever. We'll fix that if we can. The class of a dog, defines all possible dogs by listing the characteristics and behaviors they can have. Okay. The object Lassie, the object, comma, Lassie, comma, of this periods. Where did you go, my eyesight? All right. The object Lassie is one particular a dog. True. All right. With particular versions of the characteristics. A dog has fur. Lassie has brown and white fur. True. Furt. All right. There's that. Okay. So a pattern, let's give this a little space. A pattern or exemplar of a class. Let's put a little this there. A little colon there. The class of dog defines all possible dogs by listing the characteristics and behaviors they can have. The object Lassie is one particular dog. It's one particular instance of dog. I would. That's what I would say. With particular versions of the characteristics. So a dog has a fur. As pardon me. Dogs have fur, yes. Lassie has brown and white fur. So Lassie has fur, so it is a dog, and it has brown and white fur, which we can also put somewhere in the object to describe it. Makes sense. Let's go.
So dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks.
He says words like exemplar and all the other ones as if it's just stuff we say to people. Hey, when was the last time you saw the exemplar? Oh, the exemplar is over there. Come on now. What that? Well, I've never heard that word before in my life. I'm sure it has something to do with example, though, huh? Okay, let's say that.
These things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances.
All right, let's put instance down. Here we go. Who knew that we were going to be typing a book today? Terminology class, terminology instance. All right. Terminology instance. Okay, so this is like an instance of a dog. Like Lassie is a particular instance of a dog. All right. So one can have an instance of a class or a particular object. The instance is the actual object created at runtime. Very true. In programmer jargon, the Lassie object is an instance of the dog, of the dog class. Yep. That's some jargon, I guess. The set of values of the attributes of a you know what we're going to do after this? Particular object is called a state. We're gonna throw this into ChatGPT right after this, in fact. The object consists of state and behavior that's defined in the object's class. Okay. Object and instance are often used interchangeably. Object and instance are often used interchangeably. All right. You know what we're going to do? We're going to do just what I said. All right. Where are you, ChatGPT? Right here. Let's do this particular technique right here. All right. Simplify this to where someone can learn it. Someone can learn it easily. How about that? That's not how you spell that. Easily. All right, let's grab this over here. Whoop. And slap it in like thus. Put it in the oven. That's ChatGPT. All right. A class is like a blueprint that defines what an object is like. It describes both attributes, things it has, and behaviors, things it can do for an object. I love it. You're mine now. And we are going over here and we are replacing this with a little 2024 action. No, we're not. Whew. Sometimes I want to get a little wild. All right, so we're going to take it like that and maybe... Nope. All right, let's do this. Okay. Where'd the rest of it go? Oh, here it is. For example, we'll do this. For example, And then this, and drop this down like that. Okay, let's see. A class is like a blueprint that defines what an object is like. It describes both the attributes, the things it has, and the behaviors, the things it can do. It describes both the attributes and the behaviors of an object, yes. For example, a dog class could include characteristics, so breed, fur, color, what all dogs have. Behavior, barking, sitting, what all the dogs can do, true. Think of it as a plan that tells us, comrade, how to create a specific type of object, like a dog with particular traits and abilities. Okay, great. We're going to fix this one now. Do the same for this one. Do the same for this. Boom. Sweet. All right. Let's toss this up there and format it while we're at it. Boom. All right. A dog, an object is a specific example of a class. All right. All right. Okay. For instance. All right. So examples go over here. And then we'll tab all three of these over like that. Perfect. All right. So an object is a specific example of a class. The dog class describes all possible dogs, including their characteristics and behaviors. An object, like Lassie, is one particular dog created from that class, with its own specific details. For instance, we'll bring this back in. The dog class says the dogs have fur. The Lassie object has brown and white fur. So the class is the general idea, and the object is a specific version of that idea. Okay. All right, ChatGPT, way to get creative. Okay. Maybe I should drop this down. And then bring this one back. Looks like a poem now, huh? Sure, that's good enough. All right. Terminology instance. Do the same for this. Oh, this. All right, so let's grab that here and slap it in thusly. This one's taking a little while, huh? All right, let's drop this one in there. Where are you, my notes? Boom. Okay. Why is it doing it like this, though? Why is it formatting it so stupidly? Is it because I'm stupid? And so it's just following suit? Let's tab this over, actually. It's the for example. Just drop these down. Do something like this. And then like this. And then like this. All right. And let's drop this down here. Drop this down. And that looks good. All right. So terminology instance. An instance is a specific object created from a class. For example, Lassie has an instance of the dog class, meaning it is a particular dog created based on the blueprint provided by the class. True. The state of an object refers to the current values of its attributes. Ergo, Lassie has brown and white fur. True. An object combines both its state and behavior, what it can do, like barking, as defined by its class. It's getting ChatGPT The thing about ChatGPT is it gets worse the more you do it, because it wants to be lazy. An object combines both its state and behavior as defined by its class. The term object and instance mean the same thing and are often used interchangeably. Okay, so this one, simplifying this one didn't help at all, honestly. The object combines both its state, which is the attributes, and the behavior as defined by its class. Okay, well, we're just going to keep going. So let's go. Where's the video? Where's the video? Shablam. All right. Well, we're almost done with the video. We've only got like a minute left, so another 4 hours. Just kidding. Let's go.
Or objects, we know certain things about dogs. Instances or objects are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say, make me a new object using this class as its template. Oh, and now make me another one. And so we can have many, many objects from one class. So just
True.
like many cookies from one cookie cutter.
True. Okay. Hopefully this is the last one. We've got 34 seconds left, but who knows what we could stuff in 34 seconds time. All right, let's go. Terminology. Let's bring this up here. Terminology method. All right. There we go. An object's abilities. In language, I am running out of gas, aren't I? Methods are verbs. Oh, okay. Now, not just dogs and cookies. We got verbs too. Okay, Lassie. Lassie being a dog from the dog class, being a dog, has the ability to bark. True. I believe it. So the bark method is one of Lassie's methods. Methods. True. She may have other methods as well. For example, sit or eat. Sit, eat, walk. Sit, eat, walk. We're going to skip the joke because I don't care. We'll say etc. Within the program, using a method usually affects only one particular object. All dogs can bark. Can bark. But we need only one particular dog to do the barking. Method and message are often used interchangeably. All right? Method and message are often used interchangeably. All right. Let's toss it in ChatGPT to get a little refinement action. All right. Refine this. All right. Okay. Grab this, come back over here to the notes, slap it in thusly, and let's fix it up. All right. Which are like verbs in language. Uh-huh. Let's do this. Drop this down. And bring this back. I might have my notes if you're watching this. Well, I mean, obviously you're watching it. I might have my notes on my website soon. So you can just get them instead of having to do this yourself. But I don't know about today. All right, that being said, so terminology method. An object's abilities are called methods, which are like verbs in language. For example, Lassie is a dog and has the ability to bark. So the bark method is one of Lassie's methods. She may also have other methods like sit, eat, or walk. In a program, calling a method usually affects only that particular object. True, because it's calling the method on the object. So for instance, while all dogs can bark, we only want one specific dog, like Lassie, to do the barking. The term method and message are sometimes used interchangeably. So yeah, like whenever we run the upper method, right? Or whatever the method is to make everything uppercase. The object would be the string. Like if we said, like if there was a string 1 right here, let's say string 1. Oops, that's not good. 1. And then we say dot upper. 1 is the object, and then this is the method we're going to do, and it's only going to do it on this object. It's not going to do it on is. It's not going to do it on verb. It's only going to do it on 1, and then it'll make it uppercase. All right. So there's that. Let's go watch the end of the video.
Method is a bit of code that lives in these from one cookie cutter. Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented.
True. Real easy stuff. We've been doing this since JavaScript. We know what's going on. Okay, so that one's done, and now let's answer the question. Which is not true about objects in Pythons. Objects get created and used. I think that's true. Objects are bits of code and data. That sounds right. Objects hide details. I don't know about that one. Objects are one of the 5 standard data types also. I don't know about that one either, but this one sounds legit, even though we didn't really talk about it. This one sounds ridiculous because it can, but they also might not. So let's check the answer. What the hell? Objects are one of the 5 standard data types. Okay, there it is. I guess that makes sense. Okay, anyway, whatever. So we're on to the next one. Now we're on to objects, a sample class. And we'll see you next time.